All right. So as I mentioned, I think this will look familiar to you. You've been doing transformations for several years. Even in geometry, you did transformations of shapes on the coordinate grid and transformation rules. But definitely in algebra and algebra 2, you learned the basics of transformations. And this year, recently, just a couple units ago, we were doing all those transformations of the sine and cosine wave. So all the transformation rules are the same. Okay, so we're just going to review those and make sure everybody remembers them, and then do some examples on the back and with all of the functions we've been reviewing this unit. All right, so your coefficient at the beginning of the equation, we label that A. Okay, that's what's being multiplied outside the function. Okay, so it's affecting your y values. Okay, if the sign of that A affects whether or not your function is facing up or whatever direction how the parent function goes, or if it's flipped over the x-axis, if it is reflected. Okay, for this sake of consistency with my other classes and all of these notes, I'm going to use the radical function, because that's what I used in the last class, as a base. So we're just going to call this our f of x. Okay, now what we need to know is if I put a negative in front of my function, if I multiply the function by a negative, so if my a is negative, that is going to be a reflection over the x axis. Okay, so that would come here like this. So this would be negative f of x. Now, what other way can you think of that the a value, besides the positive or negative, can affect your graph? Say again? If it was a fraction, it would change the graph. How would it change it? It would compress it. Yes. Okay, so let's look at what a does if it is a fraction. So if a is between 0 and 1, okay, versus if a is greater than 1. Because typically, understood value of a is 1, because multiplying by 1 doesn't change anything. It just keeps it like the parent function. Okay, but if a is something other than 1, what happens to the graph? Okay, and it's different if it's greater than 1 versus if it's a fractional value, like 1/2 or 2/3 or 5/8 or something like that. Okay, so what happens is we said a is affecting the y value. Okay, that's why it reflected over the x, because the y values changed from positive to negative, right? So if I multiply my y values by a fraction, they're going to get smaller, right? So these values would get closer to the x-axis. They would compress down. Do y'all agree? Do y'all understand that? So when your a value is a fractional value between 0 and 1, that is a vertical. That vertical just means it's affecting y. A vertical compression. Now, if that a value is bigger than 1, let's say it's a 2, if I multiply all of these points by 2, the y value goes higher, doesn't it? Okay, so that's a vertical stretch. Okay, and we did those same rules when we did trig functions. A determined the amplitude, and so when you had an a value greater than 1, that sinusoidal wave was stretched taller. Okay, you had a larger amplitude. Okay, and if it was fractional, it squished it down. All right. Now, I'm going to go ahead, since we're talking about a reflection here, and go ahead and put some other information in the same section just as reference. Whoa. Just as reference. So what do you think happens if there's a negative, but it's not outside the function? It's not the a value that's negative. What if it's inside the function? It's the x value that's multiplied by a negative. Let's think graphically. Okay, if this point, if the x value is changed from positive to negative, where does it go? Right here, right? Same thing with this one. So what's happening? They're doing what? Reflecting over the y. Okay, so if the negative is the a, if it's outside, it's reflected over the x. But if that negative is inside, it's going to reflect over the y-axis. So far, so good? All right. Now, the next section talks about adding or subtracting a number to the x. Okay, this happens on the inside of the function. Okay, and we find the horizontal shift based on that number. Okay, and we use a h to represent it. Okay, this is going to indicate whether or not our graph is shifted left or right. Okay, so it will be shifted to the left if it's x plus h. Okay, or it will move to the right if it's negative. Okay, I mean if it says x minus h. Okay, we wrote on our reference sheet a few days ago. We actually started it last week and finished it a couple days ago. We wrote a lot of like the vertex form of equations, and they all have inside the function x minus h. Okay, so if there's a minus in there, you're actually moving to the right. The h value itself is technically positive. Okay, and when you subtract a negative, it becomes a plus here. So that's why that one's to the left and this one's to the right. Okay, so just remember that when it's inside the function, it's opposite. Okay, so we're going to use the same parent function for reference here. So if I have x minus h, that is going to shift to the right. Okay, so I'm going to pick a number for h. We'll just pick 2. So all of your points would shift over 2. That would be f of x minus 2. If we had f of x plus h, that is going to be a shift left. That would be f of x plus 2. Does that make sense? So you actually go, when it's a minus h, that's to the right. When it's plus h, that's to the left. Now, the next part of our equations that we need to look at is the number that's added or subtracted on the inside, or excuse me, that was the inside. So on the outside of the equation. Okay, and that is our vertical shift, and we use a k to represent that. Okay, the k value indicates whether the function moves up, if positive, or if it's added, or if it moves down, if it's negative, if it's being subtracted. Can I scroll up off of that previous graph, or is everybody done with that? Okay. All right, so same parent function. All right, so if I have my function and outside of it, so not in a parenthesis, so close that parenthesis, I do minus k. That is going to shift my function down. So all the points on the function get moved down. I move down 2, so this would be f of x minus 2. And then if I had my function plus k, that would be a shift up. So far, so good? Does this look familiar? Y'all remembering these rules? All right. So now we're going to do some examples on the back. But before we jump into them, I've got a little box here where we're going to list all of the transformation functions, meaning I want to list not the parent function, I want to list it with the a, h, and k, where you can see the transformation rules that would take place. So like the vertex form. Let me get my black pen back. Now for linear, you're used to seeing linear functions written as mx plus b, or y-intercept form, which we're going to stick with, but we're not going to use m and b. We're going to look at our a, h, and k. So remember, m was your slope. Okay, the parent function slope is 1. So whatever you multiply the function by changes the slope. So that is your a. A is the slope. And then b was the y-intercept. So that's vertically shifting from the origin where the parent function crosses. So that's your k. So ax plus k, it's the same as mx plus b, but we're just going to try and keep all the same variables or letters. Now the quadratic function, you'd start with a is multiplied by, and then the inside of the function is the x minus h, and it's squared because that's what quadratic it means, and then your plus k. Absolute value will look very similar, except instead of parentheses squared, it's not quadratic, it's absolute value. You'll have your absolute value bars. That's what x minus h will be inside. And then you'll have your plus k. Okay, radical, keeping the same pattern, but instead of absolute value bars, you'll have a radical, a square root. And a plus k. Cubic is going to look almost identical to the quadratic, but instead of squared, it will be cubed. Cube root will look just like the square root one, except it'll be a cube root. So there will be a 3 in that index. Now, exponential, log, and rational tend to be a little tougher. Those are the tougher functions, newer ones. These are the 3 functions that have asymptotes, right? None of those above have an asymptote. Okay, these 3 have asymptotes, just as a reminder. Okay. An exponential function has x in the exponent. So you still multiply by a, but then you have some base value b to the power of x minus h, and then plus k. So the x minus h, that's the inside of the function. It's in the exponent. Logarithmic, you'd have a times the log, some base b, of x minus h. So it's what you're taking the log of, and then plus k outside the parentheses. And last but not least, rational. Where is x in a rational function? What is a rational? What's the rational parent function? If you need to look at that reference sheet we made or look at the packet of all the parent functions from the beginning of the unit, you can. What's the rational? Where is x in a rational function? Anybody? It is 1 over x is the parent function, so x is in the denominator. Okay, so if x is in the denominator, that means h is too, right? Because it's subtracted from the x. So x minus h is the denominator. Okay, the plus k is always outside the function. And then a is multiplied by it. So if it's a 1 here, a times 1 is just a. Y'all feel okay about those? Do y'all see the pattern, the similarity? X minus h is inside, multiplying by a and adding k is outside. All right, so the first type of example we're going to look at is given a graph, state what type of function it is and describe how it was transformed. Compare it to its parent function. Okay, and then we want to write the equation. So what is this first function? Which of this list here, which type is this? Quadratic. Very good. So we have a quadratic function. Okay, and what has happened to it? How has it changed from the parent function? Yeah, it definitely went up, and that vertex is at 5 now instead of the origin, so it shifted up 5. That's for sure. Let's see, did it shift left or right any? Did it reflect? Did it stretch? So that is the only transformation is up 5. Okay, so when I write the equation, is that A, H, or K? Shifting up or down is your K. Okay, so looking at the quadratic equation over here, A would remain an understood 1, so that doesn't have to be written. That means there was no stretch or reflection happening. There is no horizontal shift, so nothing here. It would be minus 0, which does not have to be written. And then the K is 5, so it's just going to be x squared plus 5. It's literally the parent function plus 5. The parent function shifted up 5. Now, y'all were quick to say it hadn't been stretched because it doesn't look like it, but how would you actually check? How do you know if it's been stretched or not? I'm going to zoom in on that graph. What is if you think about the parent function, from the origin, the vertex of the parent function, the next point is over 1, up 1, right? Because 1 squared is 1. Okay, and then at 2, 2 squared is 4, right? Right? So on the parent function, there's a point from the vertex over and up 1, over 2 and up 4. So we see if that's the same. Here, over and up 1. Yep. Over 2 and up 4. Yep. So it keeps that same rate of change, right? So it has not been stretched. But look at this one. What type of function is this? This is absolute value, which has it been shifted anywhere? No, the vertex is still at the origin. So no left or right shift. So h and k are both 0. But in the parent absolute value function, the slope of this line is 1 to the right and negative 1 over here. Okay, so this definitely looks narrower, doesn't it? This has been vertically stretched. Okay, but we want to say by what? We need to know the number that it's been stretched by so we can write the equation. So normally it's over 1 up 1, and this is, let me get a different color here. Over 1 up 3. And then you can see over 1 up 3. Over 1 up 3. So normally the absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. Okay? But these have all been stretched higher, right? They've been multiplied by 3. Okay? So this is a vertical stretch, an absolute value. So we've got an absolute value function with a vertical stretch by 3. So if I look at the equation for absolute value, A is 3, and we said there's no shift. So h and k are both 0, so nothing to fill in there. So it is just going to be 3 times the absolute value of x. Cool? All right, what type of function is this next one? It's rational, yes. Okay, so rational functions, remember I said these are the 3, exponential, log, and rational. Those are the ones with the asymptotes. Rational is the one with 2 asymptotes, okay? Exponential had the horizontal, logarithmic had the vertical, rational has both. So you can see how this graph looks to level out both sides of the curve at this value. There's an asymptote there. Now the asymptote wasn't drawn, but you can see the behavior of the graph, right? Same thing here vertically. There's an asymptote here. So the vertical asymptote has not moved. It's still the y-axis, right? But in the parent function, the horizontal asymptote was the x-axis. So that has been moved up 5. Do y'all agree? So this is a rational that's moved up 5. There's been no stretch or horizontal movement. So when I write this equation, okay, A is the understood 1, no stretch. H is the horizontal shift. There was not one, so I don't have to put 0. And then the vertical shift was 5. K is 5. So it's just going to be 1 over x plus 5. So it's literally the parent function plus 5, just like this first quadratic one was. Are we good? All right, so that's working from a given graph. Now we're going to look at what if you're given the function and the description, can you write the equation? Do you understand what these transformations mean in terms of the equation? That's what we want to make sure that we're able to do. Okay, so it's going to be a cubic function. The vertical shift up 5. That tells me my k is 5, right? Vertical shift up and down, that's k. So k is 5. Horizontal shift, that's h, is right 3. So that's 3. There is no mention of a stretch or a reflection. So a must be the understood 1. No change to a. So when I write my function, A is 1. It doesn't have to be written. It would be understood to be a 1. Okay, in my parentheses, I would have x minus h, so x minus 3. And then they said this was cubic, so this is cubed, plus k, which is 5. So this is right 3, up 5. Remember, it's the opposite operation inside. All right, so we're going to deal with a quadratic this time with a vertical compression by 4 and a horizontal shift left 8. So horizontal shift to the left 8, so that's negative 8. When I plug that in the equation, it'll be plus 8, right? Because x minus negative 8 would become plus 8. What about this vertical compression by 4? How's that going to be represented? A, H, or K for a vertical compression? A. Okay, A is what's being multiplied. If you multiply by a number other than 1, you're going to stretch or compress the graph. So if you're compressing it, what does that mean? It's like you're putting your hands on top and bottom and squishing it, right? It's getting smaller. The height is getting smaller, okay, by 4. So it is 1/4 for the A value. If it was a vertical stretch by 4, that means you're actually multiplying by 4. But a vertical compression technically means you're dividing by 4, which is multiplying by 1/4, right? Excuse me. All right, no mention of a reflection, so it's not negative, and no mention of a vertical shift, so K must be 0. So for my quadratic function, I would have A, which is 1/4, times x minus h, which minus the negative we said will become plus 8, and it's squared because it's quadratic. There's no k, so nothing added. That's it. Okay, this next one, reflect over the x-axis, translate right 2. So right 2 means h is 2. How do I reflect over the x-axis? Again, a negative a value. Now there's no stretch, so it must be just a negative 1. And no vertical shift, so k is 0 again. So I'm going to have a negative. This is a radical function, so the square root function of x minus h, so x minus 2. All right, this last one in this section is exponential. It says vertical, a vertical shift down 9, so that means it's negative 9, right? And a horizontal shift left, so that means it's negative 1. No stretch or reflection, so A must be the understood 1. So for exponential, okay, that base, we don't know it. We'll just keep it as base B. So it's to the power of x minus h. Now, since h is negative again, that's going to become plus there. And then plus k, so plus negative 9, that's just minus 9. Any questions about that type of question where you're going from a description to write the equation? All right, the last type that you're going to be asked to do, that I'm going to ask you to do, is given the equation, you describe the transformation. You be able to graph it. Now, I don't have the graphs on here, but the second page that I gave you, the practice for you to try on your own, is you graph describing it like we're about to do and putting it on the graph. And the graph that is given has the parent function on there. So you're able to literally just transform the points from the parent function. Okay, but for now, we're just going to do our descriptions here. All right, so what type of function is this? So this is an absolute value. And I'm going to label A, H, and K, so then that will help me determine my transformation that's happening. So what is A here? 2. What is H? H is 1, because it's x minus h. The h is the 1. K is 0. There is no k. So what does the a value of 2 do to my graph? Vertical stretch by 2. Good. Those y values are multiplied by 2. What does the h value of 1 do? It's a horizontal shift to the right. Because in the equation, it's minus, right? So that's to the right. What kind of function is this? A cube root. Okay, so the cube root. All right, A is an understood 1, nothing there. H is a 3, and K is a 5. So no stretch or reflection. What's H? But what does that mean for my transformation? Yeah, right 3. And for the K, that's going to shift up 5. So right 3, up 5. Yes. Sure. All right, what type of function is this one? It's log. Okay, it's got a log in it. It's definitely a logarithmic function. All right, A is this negative, so it must be a negative 1. H is 7, and K is 3. So what does that A being negative 1 do? It's not going to stretch because multiplying by 1 doesn't change like the height, but the negative does the reflection. Good. It's going to reflect over the x-axis. And H is positive, so that's to the right 7 and up 3. It's only a stretch if it's a number other than 1. If it's a fractional value, it's a compression. If it's a value greater than 1, then it's a stretch. What type of function is 9? Exponential, good. A is the negative 3. H is a 1, and K is a negative 4. So A is negative 3. That's going to affect it in multiple ways. How is it going to affect it? It's going to reflect because of the negative, and it's going to stretch because of the 3. So reflect over x-axis, vertical stretch by 3, and then that is right 1, down 4. So that one had 4 transformations in it. All right. And 10. What type of function? Linear. Okay. What is A? The 10. No H, right? Nothing inside with the X being added or subtracted in parentheses. 8 is the K. So that means this is a vertical stretch by 10. That means your slope is 10 because the slope was 1. 1 times 10 is 10. And when I say the slope was 1, I mean in the parent function. Okay, and then this is a shift up 8. Okay, so that means your y-intercept is at 8 because it's in the parent function at the origin. All right, last but not least, what type of function? Rational. Good. X is in the denominator. What's A? 1. What's H? What 6? It's going to be negative. The H itself is negative 6 because remember it's X minus H. So for it to be a plus sign there means it must be a negative 6, which you're right, does mean left 6. Because the equation has the minus in it already. So if H is positive in the equation, it's minus. But if it's H is negative, when you plug it in, minus a negative, it's addition. All right, is there a K value? No, so no vertical shift. So no stretch or reflection or vertical shift, so that was it, just left 6. Do y'all recall most of those transformation rules? I think so. I think that should have served as a bit of a review. So now you just have that second page that I gave you that is the practice. So if you look at it real quick, it has the parent function plotted with actual points shown. So I want you, I know it says plot the new points based on the transformations. Oh, it does say, I forgot I put describe in a sentence. So I want you to describe the transformation like we just did, like up, down, left, right, stretch, reflect, whatever. Okay. And I want you to do that actually to the points and draw the new graph for the function given. Okay. So there's 6 for you to try. This is not going to be turned in. This is just for you to practice and you'll have it in your notes. And when we take our quiz that is open note, you would get to use this. Okay. I will post the completed one of this on It's Learning. So after you try them, then you can check them because we won't have a chance in class to go back and check those. Any questions? Okay, so y'all just get to work on that practice.